Start.
Science Chapter 2, Acid, Bases and Salts. First topic is acid. Acids are sour in taste. Food items which have acids are sour in taste. Examples of acid are lemon, curd, unripe fruits, etc. The given examples are common examples of acids. These items contain acids, hence they are sour in taste. Types of acids. On the basis of occurrence, acids can be divided into two types: natural acid or organic acid. Acids that are obtained from natural sources such as plants, animals, etc., are called natural acids. They are also called organic acids. Examples: citric acid, acetic acid, etc. Mineral acid or synthetic acids. Acids that are prepared from minerals are known as mineral acid. Example: hydrochloric acid, sulfuric acid, and nitric acid are common mineral acids. And as mineral acids are prepared in laboratories, thus they are known as man-made or synthetic acids. Strong and weak acids. Strong acids. All mineral acids are strong except carbonic acid. For example, sulfuric acid, hydrochloric acid, etc. Weak acids. All organic acids, i.e., naturally occurring acids, are weak. Example: oxalic acid, formic acid, etc. Concentrated and diluted acid. Aqueous solution in which volume of constituents of acid is maximum is called concentrated acid. Concentration is defined as the abundance of constituents divided by the total volume of mixture. Concentration of acid decreases with decrease the volume of constituents. Dilute acid. Aqueous solution of acid in which volume of constituents is not maximum is called dilute acid. Dilution of acid increases with increase of in solvent. How do we dilute acids? Acids can be diluted by mixing of acid into water. Dilution of acid is an exothermic process. Bases. Bases have a bitter taste. They are soapy when touched. Bases turn litmus paper into blue. Example of bases are caustic soda, washing soda, potassium hydroxide, slick lime, etc. All metal oxides, metal hydroxides, and metal carbonates are bases. Chemical properties of bases are just opposite of acids. When a base is added to acids, both neutralize each other. In such reaction, respective salts are formed along with water oxide, hydroxide, and carbonates. All metals are a base. Example: calcium is an alkaline earth metal. Thus its oxide, calcium oxide, its hydroxide, which is known as calcium hydroxide, and calcium carbonate are base. Types of bases. There are on the basis of solubility in water, there are two types of bases: water soluble base, or which are known as alkalis, and water insoluble base, which are common bases. Most of the bases are insoluble in water. Alkalis. What the bases which are soluble in water are known as alkalis. Alkali is a basic ionic salt of alkaline metals. Lithium, sodium, potassium, etc. are all alkali metals. Beryllium, magnesium, calcium are alkaline earth metals. Therefore, hydroxides of alkali and alkaline earth metals are called alkalis. Example: sodium hydroxide, calcium hydroxide, potassium hydroxide, etc. All properties of acids. Acids are sour in taste. Acids give H plus hydrogen ion with water. They turn the color of blue litmus paper to red. Acids conduct electric current. It reacts with metal to produce salt and hydrogen gas. Properties of bases. Bases are bitter in taste. All bases give OH minus hydrogen ion with water. It turns color of red litmus paper to blue. Bases conduct electric current. They react with metal to give salt and hydrogen. Acid-base indicators. There are substances which indicate by changing in color after testing acids and bases. They are of two types: natural indicators and synthetic indicators. Natural indicators, examples of natural indicators are litmus paper, turmeric, and red cabbage. Synthetic indicators. Methylene orange. Methylene orange is a synthetic indicator. These indicators tell whether a substance is acidic or basic by changing color. Olfactory indicators. There are some substances whose odor changes in acidic or basic media. They are called olfactory indicators. Example: vanilla, onion, and clove. Universal indicators. Universal indicators show different color over the range of pH value from 1 to 14 for the given solution. Universal indicators are available in both forms of strips and solution. The color matching chart is supplied with the universal indicator, which shows the different colors for different values of pH. Chemical properties of acids and bases. Reaction with acids and metals. Acids react with metal to give corresponding salt and hydrogen gas. Testing of hydrogen gas. When we react any metal with acid, the reaction gives corresponding salt and produces hydrogen gas. When we place a burning candle nearby gas, it produces a pop sound. The pop sound indicates that the produced gas is hydrogen. Reaction of metal carbonate, metal hydrogen carbonate with acids. Limestone, chalk, and marble are different forms of calcium carbonate. All metals and hydrogen carbonate react with acids to give a corresponding salt, carbon dioxide, and water. The reaction of metal hydrogen carbonate with acids, general form. Metal hydrogen carbonate, also known as bicarbonate, plus acids gives salt, carbon dioxide, and water. Bases react with metals given bases with react with metals give corresponding salts and hydrogen gas. Example: sodium hydroxide reacts with zinc, gives sodium zincate and hydrogen gas. Historical monuments and acid rain. Acid rain causes damage to the historical monuments and other buildings. For example, Taj Mahal, which is made up of marble, is getting damaged because of reaction. Acid reaction with rain. Marble is a calcium carbonate which reacts with the acid and thus gets corroded. Use of the reaction between acid and metal carbonate or metal bicarbonate or in fire extinguisher. Metal carbonate or metal hydrogen carbonate and acid are used in fire extinguisher to produce carbon dioxide gas. Acid and metal carbonate or bicarbonate are kept in separate chambers in a fire extinguisher. On emergency, they are allowed to react with each other. The carbon dioxide gas is produced to put over the fire. Neutralization reaction. A reaction between an acid and base to give salt and water is known as a neutralization reaction. Reaction with acid and bases. Example of reaction with acid and bases are sodium hydroxide react with hydrochloric acid to produce common salt and water. Reaction of metal oxides with acid. Metal oxides are basic in nature, so they react with acid to give salt and water, like neutralization reaction. Example: copper oxide reacts with hydrochloric acid to give copper chloride and water. Reaction of bases and non-metallic oxides. Non-metallic oxides are acidic in nature, which react with base form to form salt and water, which are same as neutralization reaction. Example: sodium hydroxide reacts with carbon dioxide to give sodium carbonate and water. Ions. Charged atoms are known as ions. Ions are of two types: cation and anion. Cation carries a positive charge on atom, anion carries negative charge on atom. All acids generate hydrogen gas when reacting with metals. So hydrogen is common to all acids, but all compounds having hydrogen are not acids. As acids have H plus ion, for example, if we take three substances, vinegar, glucose, alcohol, the chemical formula of vinegar is CH3COOH, glucose is C6H12O6, alcohol is CH2CH3OH. These all have hydrogen. Next topic is salt. Salts are compound formed with acids and bases. Natural salts are formed from a strong acid and a strong base. Basic salts are formed from a strong base and a weak acid. Acidic salts are formed from a strong acid and a weak base. Example of acidic salt is NH4Cl. pH scale. The concentration of hydrogen ion in a solution can be determined using the pH scale. In the word pH, P stands for potency or power, and H stands for hydrogen ions. The pH scale is a tool using which hydrogen ion concentration is measured. pH scale works from a value of 0 to 14. 0 value indicates highest acidic substance. 7 value on pH scale indicates the neutral solution, and 14 on pH scale indicates highly basic solution. Chloralkali process. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. This process is called the chloralkali process. This process is taken by electrolytes of aqueous sodium chloride. When electricity is passed through an aqueous solution of sodium chloride, chlorine gas is given off at the anode, and hydrogen at the cathode. Sodium hydroxide solution is formed near the cathode. Uses of sodium hydroxide. It is used for degreasing metals, in soaps and detergents, in paper making, and for making artificial fibers. Uses of chlorine gas. It is used in water treatment, in swimming pools, in manufacture of PVC, CFCs, and pesticides. It is also used as disinfectants. Uses of hydrogen. It is used as fuel. It is used as marganite in manufacture of ammonia or fertilizers. Production of hydrochloric acid. Chlorine and hydrogen are main products of chloralkali process. They are used for production of hydrochloric acids. Hydrochloric acid is an important chemical product which is used in manufacturing of medicines, cosmetics, and ammonium chloride, and it is also used for cleaning steels. Production of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime. This chlorine gas is obtained from electrolysis of aqueous sodium chloride of chloralkali process. Bleaching powder, abuses of bleaching powder are, it is used for, bleaching powder is used for lining in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry. As an oxalic agent in many chemical industries, and it is used for disinfecting water to make it free of germs. Baking soda. Chlorine produced on passing electricity through brine solution undergoes reaction with ammonia, produces baking soda. The chemical name for baking soda is sodium hydrogen carbonate. It, it is a mild, non-corrosive basic salt. Baking soda undergoes reaction with mild edible acids such as lactic acid to manufacture baking powder. This baking powder, on heating, undergoes the following reaction. Sodium hydrogen carbonate plus hydrogen makes water plus carbon dioxide. This carbon dioxide produced makes bread or cake rise up and make them soft and spongy. It is an alkaline. It is also an active agent in anticides that acts by neutralizing the excess acid produced by the stomach. It is also used in soda acid fire extinguishers. Washing soda. It is another chemical derivative of sodium chloride. The heating of baking soda produces sodium carbonate. This sodium carbonate undergoes recrystallization to give off washing soda. Uses of washing soda. It is also a basic salt. It is used for it is used in glass, soap, and what paper manufacturing industries. It is also used in the manufacture of sodium compounds like borax. It is also used as screening agent for domestic purposes. It also plays a pivotal role in removing permanent hardness of water. Water of crystallization. The fixed number of water molecules present in one formula unit of salt is called a water of crystallization. Uh, for instance, there are 5 molecules of water in one formula unit copper sulfate, and hence the chemical reaction of hydrated copper sulfate is CuSO4 5H2. Copper sulfate crystal. Next topic is plaster of Paris. Calcium sulfate hemihydrate. This is known as plaster of Paris. Plaster of Paris is used in the following way. It is used for supporting fractured bones in the appropriate position. It is used for making toys, materials for decoration, and for making smooth surfaces. Yes, sir.